the European Space Agency has placed a brand new cosmic detective deep in space. Since the summer of 2023, the mission has been nothing short of ambitious. Named Euclid, it aims to capture and map nothing less than the entire known universe, giving us an even better understanding of the function of dark matter in space. This new space telescope will image billions of stars and galaxies with sharper detail than ever before. The brilliance of the images will surprise you, and the level of detail will even surpass NASA's James Webb telescope. You might wonder, why do we actually need another space telescope and another map of space? Don't we now know roughly where all the stars and galaxies are? Well, to some extent, yes, but never before in the history of humankind has a telescope been able to map the sky and the entire spectrum of stars as precisely as Euclid. The telescope's mission, which will last at least 6 years, is by no means just about capturing light and taking beautiful pictures of stars. The European Space Agency has something very special in mind with its new space detective. Thanks to Euclid, European scientists want to uncover the secrets of dark energy and dark matter for the first time. Although they are said to make up 95% of the universe, these two essential building blocks of the cosmos have never actually been seen or measured. Euclid's task is to decipher the secret structure of the universe. It all began on July 1, 2023, from the Cape Canaveral spaceport in Florida, USA. On board a powerful SpaceX Falcon 9 rocket, the Euclid Space Telescope began its journey into space. After successfully launching and leaving Earth's atmosphere, the rocket set the telescope on its way to the Sun-Earth Lagrange point 2, about 1.5 million kilometers from Earth. Along the way, the telescope performed a series of maneuvers to precisely adjust its orbit. Once it reached L2, an intensive phase of calibration and testing of the scientific instruments began. Euclid is equipped with a state-of-the-art 1.2-meter primary mirror. The visible light camera, VISIs, and the near-infrared spectrometer and photometer, NISP, will capture even the faintest light from the most distant stars, providing us with full panoramic images of space. Euclid opened its eyes for the first time, and the initial images took astronomers' breath away. The density of stars that Euclid can image is incredible, and these test images are just the beginning. Euclid is one of the most precise missions ever launched, and the technology provides razor-sharp images that will allow us to observe stars and galaxies up to 10 billion light-years away. Euclid constantly scans the sky, and every 75 minutes, the telescope aligns itself with a new patch of sky. It's controlled fully automatically by a fine guidance sensor, which consists of optical sensors that independently aim at stars. The sensors then transmit their information to the attitude and orbit control system, and in this way, the two navigation units determine the alignment and scan area of the sky, largely independently, over the entire course of the mission. As you can see, this all-sky image shows the entire night sky with almost 1.7 billion recognizable stars. Brighter regions indicate denser concentrations of stars, while the darker regions correspond to areas of the sky with fewer bright stars. The bright horizontal structure is the flattened disk of our own Milky Way, and the galactic center can be seen in the middle of the image. The bizarre play of colors is created by blue and red components in the captured light signals. The two bright objects in the bottom right of the image are the Large and Small Magellanic Clouds, both of which orbit the Milky Way. Incredible! One of the most striking discoveries captured by Euclid is the Perseus Cluster. This image shows more than 1,000 galaxies in the Perseus Cluster, which is around 250 million light-years away from Earth. Another 100,000 galaxies can be seen in the background. Scientists hope that this image will shed light on the existence of dark matter. Thanks to the unique combination of photographic and infrared images, the telescope can capture a very large and very detailed area of the universe with a single image. Over time, this will slowly create the largest three-dimensional map of the universe ever made. One of the other fascinating images Euclid has produced is of the Hubble Space Telescope's previously photographed Hubble Head Nebula. However, Euclid offers us a much wider view of the surrounding region of this nebula, located in the constellation of Orion, about 1,500 light-years away. Unlike the Hubble and James Webb telescopes, Euclid can image large areas of space around individual objects, allowing for a unique perspective on star-forming regions. So, how did ESA manage to make this telescope deliver images that no other telescope in the world can? The technology behind Euclid is actually both simple and effective. The 1.2-meter mirror collects even the faintest light and splits it into visible and infrared light waves. These pulses are then passed to the visible instrument, VISIs, and the near-infrared spectrometer and photometer, NISP. VISIs' task is to take very sharp images of galaxies in space. Since there's no interfering light from Earth's atmosphere, the camera systems placed directly in space can provide far better images than most ground-based telescopes. VISIs collects visible light in the range of wavelengths from green, 550 nanometers, to near-infrared, 900 nanometers. The device uses a mosaic of 36 camera sensors, each containing more than 4,000 pixels. This gives the detector around 600 megapixels. VISIs, therefore, has a very large field of view, and researchers want to get to the bottom of the structures hidden in it by means of compressed representations of large areas of space. If successful, this could even help prove the existence of dark matter in space. The NISP system is used for spectroscopic measurements to record the redshift of galaxies, which cosmologists use to calculate the distance and direction of movement of galaxies. Euclid's near-infrared spectrometer and photometer will perform the largest and most accurate 3D scan of the universe. NISP has the largest field of view ever built for an infrared telescope. The instrument measures infrared light in the 900 to 2000 nanometer range with a grid of 16 detectors, each providing 240 pixels. It's clear that Euclid will provide a whole new perspective on our universe. Despite their position deep in space, telescopes like Euclid are not entirely safe from stray light phenomena. It occurs when light from objects outside the telescope's intended field of view enters the instrument and causes unwanted reflections and distortions. This can reduce the contrast and clarity of observed celestial bodies and make it more difficult to capture faint or distant objects. Euclid has been specially designed and equipped to minimize the effects of stray light, allowing it to accurately observe even the faintest and most distant galaxies. A key element in Euclid's design is its special sun shield. Euclid always looks away from the sun, into the darkness of space, but sunlight coming from behind could interfere with the images. A special device effectively shields the telescope from this sunlight and protects the sensitive observation and measuring instruments inside the telescope from interference. In the beginning, the technology didn't work perfectly, and scientists had to deal with stray light issues that affected the VIS instrument. However, these issues were addressed, and by the beginning of November, ESA proudly presented a series of fantastic images. IC 342, a large spiral galaxy hidden behind our own Milky Way, had previously been barely visible due to the dust and light of our galaxy. Now, researchers have obtained sharp and detailed images of this hidden galaxy. The blue regions represent areas with younger stars, while the yellow and red regions indicate areas with older stars. The color differences arise from the scattering of light. Red light took longer to travel, so we see older light sources, while blue light traveled more quickly. Galaxies like IC 342, with their harmonious and almost perfect geometric shapes, are seen by researchers as a possible key to understanding dark matter and dark energy. These forces are believed to play a significant role in the formation of such beautiful cosmic structures. Another galaxy, NGC 6822, an irregular galaxy that was probably formed by the collision between two or more galaxies, is also a subject of study. Collisions between galaxies create chaotic conditions before previously unknown forces seem to pull the stars back into more harmonious shapes. Understanding these processes could provide vital insights into how the universe's blueprint works. Finally, Euclid has provided the clearest and most detailed images ever of the globular cluster NGC 6397 within our own galaxy. These millions of stars are some of the oldest stars in our galaxy, and possibly some of the oldest in the universe. This groundbreaking mission is offering the most detailed pictures of the cosmos we have ever seen, and scientists are excited to learn more about the hidden forces that shape everything we know about space. So stay tuned and subscribe because the best discoveries are still yet to come.